talk about solving linear inequalities. This should be review for most of you, but let's just go ahead and work some examples. So if I want to solve the inequality x plus 7 is less than 2, similarly to solving an equation, I can subtract 7 from both sides and end up with x is less than -5. Now, what may be different in this class than what you've done before, instead of leaving it just as the inequality, I can now specify it as a set. This is a set of all x such that x is less than -5. And the set of all x's that are less than -5, if I want to put that in interval notation, that's the interval from -infinity to -5, since this is a strict inequality that does not include the endpoint. Another example. One half x plus 2 is greater than or equal to 8. Just like we subtracted 7 from both sides, we can subtract 2 from both sides and get 1 half x is greater than or equal to 6. And now to get rid of this 1 half, what I want to do is multiply. But we have to be careful whenever we multiply and divide. Although since 1 half is a positive number and what I would want to multiply by to get rid of it is 2, multiplying both sides by a positive 2 is not going to change my sign because it is positive. And so I'm left with x is greater than or equal to 12, which I can put in set notation. And I may even specify this is the set of all x's in the set of real numbers, so that x is greater than or equal to 12. And if I want that in interval notation, all the x's that are greater than or equal to 12, well, that'll start with 12 and go to infinity. I do include the endpoint here. This is a greater than or equal to. So our next example, move my sheet of paper up. So now I have the inequality, -1/3 x is greater than 4. I want to get rid of this -1/3. The way that I'm going to do that is multiplying both sides of this inequality by a -3. I'm just going to be very explicit about this and write that out. When I do that, I'm multiplying by a negative number, so my inequality symbol needs to change. It was a greater than, it needs to become a less than. So this side becomes just x. This side is a -12. So I've got x less than -12, which I can write with our set rule notation. Or, as an interval, I can, this is the x's that are less than -12. Since it's less than, well, it's on the left side of it, so -infinity to -12, since there is no or equal to, it does not include that endpoint. For our last example in this video, we'll have negative 2x plus 5 is less than or equal to x plus 26. So now we want to get all of our x's on one side, and it would be something that we could do to move the x's to this side, and then everything would be positive and lovely. Now you would be flipping the entire inequality over at the end, but that some people find that easier. I am going to move this x to be over with this 2x, so I'm subtracting x from both sides, which gives me a negative 3x. Remember, I don't flip the inequality when I subtract. I'm going to move this 5 over here. And finally, I have a negative 3x is less than or equal to 21. I want to divide both sides by a negative. I'm actually going to rewrite my inequality to do that. When I do this division, as soon as I do it, I need to flip my inequality. That gives me as x is greater than or equal to negative 7. And finally, I can write my answer in set notation. So it's the set of all numbers, so that x is greater than or equal to negative 7. Or I can write it in interval notation. And this is all the x's that are greater than or equal to negative 7. So negative 7 is the smallest that it could possibly be. And then it can be anything larger than that. So that's the interval from negative 7 to infinity. Now, generally, we would I've given our answer in both set rule form and interval form for each of these problems, but that's not necessary. Really, only one or the other is necessary, and in general, you'll be told which to use, whether I want your answer in set rule notation or in interval notation.